You're welcome back to our lesson on mechanics, and in today's lesson, we'll discuss the equilibrium of particles. This is God Maths, where mathematical literacy begins. Stay tuned. A particle is said to be in equilibrium if the sum of all forces acting on that particle is zero. In our previous lesson, we discussed that the sum of all forces acting on an object is called the resultant force. And so we would say that a particle is said to be in equilibrium if the resultant force acting on it is zero. We also discussed in our previous lesson that in solving questions involving forces, we must always resolve all forces into the column or component form before we start with our calculations. Let's take one example under equilibrium of particles. Three forces F1, F2, and F3 are in equilibrium with a fourth force F4. And we want to find the fourth force, which is F4. So we are given the forces F1 to be equal to, we resolve it into the column form, and that is 2, -5. The first value is the x component and the second is the y component. Then our second force F2 will be 6 and then 1, since this is 6i plus 1j. The third force F3 is equal to -1i, so the x component is -1 and the y component is 15. Then the fourth force is what we want to find, so we represent that by x, y. Now, it should be noted that since all the forces are in equilibrium, then it means that the resultant force R is equal to 0. So R is the resultant force. Where in our previous lesson we learned that resultant is the sum of all the forces acting on an object. So R is equal to F1 plus F2 plus F3 plus F4. But remember that R is a zero vector, or in other words, we say the resultant force is 0 because the forces are in equilibrium. So we would have 0, 0 to be equal to F1 is 2, -5, F2 is 6, 1, F3 is -1, 15, and then F4 is x, y. So we want to find x, y, which is the fourth force. Now let's put the vectors together. Putting these vectors together, we will have 0, 0 to be equal to 2 plus 6 minus 1. That will give us 7. Then plus x. Then -5 plus 1 plus 15. This will give us 16 minus 5. That is 11 plus y. And so we will have 7 plus x is equal to 0, which means that x is equal to -7. And then 11 plus y is equal to 0, which means that y is equal to -11. And so finally, our fourth force, F4, will be equal to -7, which is x, and then -11. Remember that the forces were given in the Cartesian form, so our final answer should also be given in the Cartesian form as -7i minus 11j. In another instance, where the forces are given in the magnitude and direction form, our answer should always be in the magnitude and direction form. Let's take a second example on this. So, a particle is at rest under the action of three forces. Two of the forces are P 3 newtons 30 degrees and then Q 5 newtons 300 degrees. So we want to find the third force. Now when a particle is at rest, then it means the particle is in what we call static equilibrium. So at rest means the particle is in equilibrium. And when a particle is in equilibrium, then the sum of all forces acting on the particle is 0. And so the sum of the forces P, Q, and the third force should be equal to 0, which is the resultant force. So the force P, when we resolve it into the column form, we have 3 sine 30, 3 cos 30. This has been discussed in our previous lesson, and that will give us 1.5 and then 2.5981. Then the force Q is also 5 sine 300 and then 5 cos 300, and that will also give us negative 4.3301 and then 2.5. Let A be the third force. Then it implies that P plus Q plus A should be equal to R, where R is the resultant force. So where R is resultant force. But since the particle is in static equilibrium, then it means that R, which is the resultant force, is 0. And so we will have the force P, which is 1.5, then 2.5981 plus the force Q is negative 4.3301 and then 2.5 plus the force A, and that is equal to the resultant force. But the resultant force is 0. So in the vector form it becomes 0, 0. This is a 0 vector, 0 on the x-axis, 0 on the y-axis. And so when we sum this, then we will have negative 2.8301. That is this component and this component. And then when we sum the components here, we will have 5.0981. And that should add to A to give us 0, 0, which is the resultant force. And so finally, A will be equal to 0, 0 minus the force here. So negative 2.8301, then 5.0981. And that should give us, negative of this will give us 2.8301, and then this becomes negative 5.0981. Then the magnitude of A, remember that the forces were given in magnitude and direction form. So we need to find the magnitude of A, which is equal to square root of the square of both components. So 2.8301 squared plus negative 5.0981 squared. And when we find this with a calculator, we should get 5.83 newtons. Then to find the direction of A, we represent the vector A on the Cartesian plane. The x component of A is positive, so the x component should be here. The y component is negative. This is negative y component. On the Cartesian plane, we have the y, x, negative y, and negative x components. So that means the point x, y will be in this quadrant. And so supposing this is a force, then we have a triangle formed here, where we know that the x component is 2.8301 and the y component is 5.0981. Remember that we don't add the negative to this because it only tells us that the direction is downwards, or this is in the next quadrant or the second quadrant. So we want to find the direction. Let's find the small angles here, which we will represent by alpha. Then tan alpha is equal to, tan in trigonometry is opposite divided by the adjacent. And so tan alpha will be 5.0981 all over 2.8301, which means that alpha will be the tan inverse of 5.0981 over 2.8301, and alpha should give us 60.96 degrees. But we learned that the direction is always measured from the north, so the direction should be measured this way. But you already know that this quadrant is 90 degrees. So our total direction, which we call theta, will be equal to 90 degrees, that is the first quadrant, plus alpha, which is 60.96 degrees, and that gives us 150.96 degrees. So finally, the third force, which is A, so therefore the third force A is equal to, the magnitude of A is 5.83 newtons, and then the direction of A is 150.96 degrees. Let's take another example on this. A body is acted upon by the forces F1, F2, F3, and F4, all given in the magnitude and direction forms. If the body remains in equilibrium, find the values of x and y. So we have learned that before dealing with any calculations, we must first resolve all forces into the component form. So we resolve the forces F1, F2, F3, and F4 into the component form using magnitude sign direction, magnitude cos direction. This was discussed in our previous lesson and in the previous examples. So the forces have been resolved to get this as our F1, F2, F3, and then F4. Here x sine 0, since sine 0 is 0, 0 times x will give us 0. Cos 0 is 1, so 1 times x give us 1. Sine 240 is negative 0.8660, and that is multiplied by y. Then the sum of all the forces is what we call the resultant force R, where the resultant force R is a zero vector. R is a zero vector because the body remains in equilibrium. And equilibrium means that the sum of all the forces acting on the particle is 0. So we sum the forces here and that should be equal to r, which is a 0 vector. From here, we do our calculation on vectors, that is add all the x components, add all the y components. So the sum of the x components gives this, and the sum of the y components also gives this. That's equal to the 0 vector. And then with equality of vectors, we can equate the x components, and that is what we've done here. When you do that, since it contains only the variable y, you can find the value of y. Then we equate the y component, which also contains the variables x and y. So we put the value of y in place of y here, and then we can also find the value of x. We will take our last example for this lesson. This is our last example for this lesson. And in this example, 5 forces, all given in the magnitude and direction forms, acts on an object. If the object is at rest, we want to find the values of P and Q. The forces are P, 30 degrees, 2 newtons, 45 degrees, 5 newtons, 90 degrees, and then Q, 150 degrees. Then finally 8 newtons, 270 degrees. These are the 5 forces that are keeping the objects at rest. And once the object is at rest, it means that it is in static equilibrium. Now we convert all the forces into the components or the column forms. Because the forces were given without notations, we will let F1, F2, F3, F4, and F5 represent the forces. And we have converted them to the column forms as done in our previous examples. Now the sum of all the 5 forces should be equal to the vector 0, 0, which is the resultant force. And the resultant force is a 0 vector because the body is in equilibrium. Now, when we sum all the forces F1, F2, F3, F4, and F5 and equate to the resultant force, which is 0, 0, then we will have 0.5p plus 0.5q minus 1.5858 to be equal to 0. That is equality of vectors. And then the y component should also be equal to 0, which is the y component at the other side of the equation. Then this will give us a simultaneous equation. So we take the number 10 to the other side of the equation. Now, when we get here, we divide through by 0.5, which is the coefficient of both P and Q. So we divide through by 0.5, and then that gives us P plus Q to be equal to 3.1716, and we denote that by equation 1. Then we take the y components and equate them. So we will have 0.866p minus 0.866q plus 1.4142 to be equal to 0. When we group like terms, or we send the number 10 to the other side of the equation, we have negative 1.4142. Then we divide through by 0.866, which is the coefficient of both P and Q. And that gives us P minus Q equal to, when we divide this by 0.866, we have negative 1.6330. Then finally, we add equations 1 and 2. That is done to eliminate the variable Q. So when we add 1 and 2, we will have P plus Q, which gives us 2P, and then 3.1716 plus negative 1.6330. That also gives us this. So we divide through by 2, and then finally our P is 0.77 newtons. Then we put the value of P into the first equation, and then we group like terms to find the value of Q. Remember that we are using 4 decimal places for our calculations. Then our final answer is supposed to be given in 2 decimal places. So finally, we have the value of P to be 0.77 newtons and a value of Q to be 2.40 newtons. So we will take one question as an assignment for today's lesson. Now this is our assignment for today's lesson. Solve it on your own. Send us your answers via WhatsApp on the number displayed on your screen. You can always contact us if you have any extra difficulty on this lesson through our social media handles or through our WhatsApp number. Remember to subscribe to this channel for more interesting lessons. In the next lesson, we will discuss how to use the Lami's theorem and the triangle of vectors to find the equilibrium of 3 forces that are acting at a point. See you in our next lesson.